All right, so these are 9 questions that are exactly like the mastery. All right, y'all, thanks for being here. All right, so these 9 questions are exactly like what is getting ready to be on the retake. So a couple things to remind you about, and somebody tell me real quick, y'all can see my screen, correct? So I can make sure I'm not about to just go off and you guys don't know what I'm doing. All right, cool beans. All right, so remember that the domain of your relation, so the domain of your graph is your x values, right? So the first thing we are going to do is look at where those x values start and where they end. And that's how we're going to determine the domain. So we're looking along the x-axis. That means we're looking along here, right? So where does the domain start on that graph? It starts right there at those 2 coordinates. And they're lined up along with at the -2 on the x-axis. So that's -2 right there on the x-axis. I'll take my line off there just so you can see like where it lines up with the -2. So that means that our domain starts at -2. Now my boxes aren't going to turn green like yours will because I'm doing it on the teacher side. Excuse me. So our domain is going to start at -2. And we need to decide what type of bracket we're going to use for it. So we have here a continuous function, which I'm going to go ahead and fill in the blank next to that. The reason we know it's continuous is because I can draw this graph without picking up my pencil. So because it's continuous, that means that the domain isn't just -2, and it's not just where it ends either. It's all these coordinates in between, which means that we need to represent the domain with interval notation. So remember that interval notation is either a hard bracket or that soft parenthesis, one of the two. That's what we use for interval notation. And again, the reason we're doing interval notation is because this is continuous. So we have to account for like all the numbers in between because they're not just isolated numbers. So the -2, these 2 coordinates, notice are open circles. So that, what do we use when it's an open circle? You're going to remember from when we did interval notation that means it's going to be a parenthesis. Yes, sir. You're right, Jay. So we're going to use that soft parenthesis. And now we need to add our comma and see what's going to be on the other side of that domain. So we need to look at where the ending point, which if we're going along the x-axis is going to be right here. So that lines up with +2 on the x-axis. So +2 is going to be the right side of that interval. And unless there's an open circle, like here, we can clearly see on the left-hand side, we could clearly see that this was an open circle, right? Obviously, because it's like open. If you don't have an open circle, you automatically assume that it's a closed circle. So we're going to assume that that is a solid coordinate, which means when we put our +2 over on the other side, we're going to use that hard bracket. So mine's not popping up with the number to tell me that I did it correctly, but yours should be since you're doing the class kick on your side. So that would be the domain for that particular graph. Now we need to take a look at the range. Oh, well, first of all, I'm sorry. Let me pause here for a second. Any questions about where I got that domain from? All right. So the range, if the domain was my x values, then that means that the range are my y values. So I'm going to write a little y here as a reminder. Our y values would fall along the x-axis here. So we're basically looking at the bottom and the top of that graph, right? So the bottom of the graph is right here at -2. That's the low point. The top of the graph is up here at +2. We know we're doing interval notation, so we know that it's going to go from -2 to +2. Now, with it being interval notation, we've got to decide whether it gets a parenthesis. Oh, cool beans. Okay. And if we need to go back, Montel, I can always, I'm recording this too, honey. So you can go back, or I can just tell you what we did for the first part. Gotta love technology, don't you? You can't see my screen? Like, you can't see the problem I'm writing right now? All right, so we've established that the range is the low point of that graph and the high point of that graph. So we've got -2 and +2. And because this is a continuous graph, we have to decide whether it's going to get a parenthesis or the square bracket. In both cases, our low point and our high point are represented by that open circle. So that means that both sides of the interval notation are going to be the soft parenthesis, just like that. So any questions about where I got that range from? Okay, we already established it's continuous because I can draw it without picking up my pencil. And the last thing we need to do is determine whether or not it is a function. So if I draw a vertical line straight through that graph, it's going to hit it in 2 places. So that means it is not a function. It's not a function because it failed that vertical line test. So any questions about where those answers from number 1 came from? Okay, I'm going to shut up for just a minute. I'm going to set a timer for like 3 minutes. Give you a chance to at least take a good educated guess about what you think those answers are for number 2. Don't worry, I'm going to work them for you, but I'm going to give you a minute to think. Okay, so for number 2, let me kind of zoom in here a little bit for you guys so it's a little easier. Oh. I said zoom, iPad. Okay. So the domain is going to be our x values, like I just said in the first example. So if we're looking along the x-axis, our x values start the left side of the graph, starts right there at -5. We know, I'm going to go ahead and write this is continuous because we can draw that circle without picking up our pencil. And also because it's continuous, that means we're going to need to use interval notation for the domain because it's not just the start and the end point, which is right here, by the way, at +3. It's also all these coordinates in between. So that is why we need to do interval notation. And these 2 endpoints, these 2 coordinates are clearly closed circles. So we should have hard brackets for each of those. Looking at the range, I need to look at the bottom of my graph and the top of my graph. And so the bottom, sorry guys, I'm grabbing my microwave, but I think you can still hear me. So the bottom of my graph is going to be -3. So that's my range. My high point on my graph is +5. And remember that you assume that it is a closed circle unless you see an open circle. So we're going to assume those are coordinates, solid coordinates, which means we need brackets on either side. We need the hard bracket. For -3 and 5, is this a function? Well, if I draw a vertical line, that was a really ugly vertical line, but if you draw a vertical line through it, we're going to hit it in more than one spot. So once again, this is a no. Okay, so that's 1 and 2 for continuous functions. Any questions about where any of those answers came from? Okay, I'm going to take that radio silence as we're good. Thank you, Montel, for answering me. All right, number 3, I'm going to go ahead and work for you because I know this is a little different from 1 and 2. It's pretty easy, but it's so different from the others, it's easier to forget. So we're still being asked for the domain and the range. First of all, this is not a continuous function anymore. This is going to be discrete. And it's going to be discrete because you can't possibly draw this correctly without picking up your pencil, right? It would just be all the little dots. So what I would do personally, in order to find the domain and the range, I would actually go through and label each coordinate first. So what I mean by that is, for example, this coordinate would be -3, 1. This coordinate is -2, 0. This coordinate is 1, 4. This coordinate is 2, -5. And then this coordinate is 5, 1. So because I'm visual, it's just easier, in my opinion, to go ahead and label all those coordinates to make it easier to see. And then the domain is just going to be a list of all of your x coordinates. Remember when you're doing domain and it's of isolated coordinates like these are, like we're literally just about to make a list. And the list should go from least to greatest. So that'll be -3. Oh, help if I had a pen, not a highlighter. Sorry, folks. So I've got -3, followed by -2, followed by 1, +2, and 5. So I'm just putting all those x coordinates in order from least to greatest. And when it's a discrete function, we're not doing interval notation. We don't have like lines in between that we need to keep track of. So remember, when it's interval notation, is that you need to put the little curly braces on either side. So not the parentheses or the square brackets. You need to put the little curly Q braces. And then it should pop up as correct. I see a couple of you guys typing, so I'm going to give you just a sec. Great question. So basically, you remember back when we were solving like absolute value equations where you had to do a case 1 and a case 2, so you came up with like 2 different answers. So you came up with like your case 1 might be x is equal to 2, y is equal to 6. And you had, whenever you had 2 answers, or I'm sorry, not y is equal to 6, x is equal to 6. Like you had to do a case 1 and a case 2, and you had 2 different solutions. Basically, the old white dudes who invented the rule said, anytime you're just listing more than one number, you need to use those curly Q braces. So honestly, it's just because the difference between the braces and what we did in the previous example is that in the previous examples, those were continuous functions, right? So we didn't just have, like, say we'll look at the domain here. We didn't just have -5 and +3. We had all the numbers in between as well. And so to represent that idea for function notation, you use the square bracket or the parenthesis. But whenever you're just literally listing, so these are just individual numbers, right? Like -3, -2, 1, 2, 5. We're not listing the numbers in between them. So that's why we use the curly Q braces, just to say we're only talking about those particular numbers. And that's all I really got for you. It's just whoever made up the rule about how you do the notation, that's the rule they decided to make up. That's kind of all I got. You're welcome. Okay, range. Now that we've got all those coordinates listed, we know that the range is going to be the y values of each of these coordinates. So I'm going to do exactly the same thing where I'm going to do curly Q braces. I really can't draw those guys, sorry. And then you just put them in order from least to greatest. So that would be -5 if we're working our way up. So -5, 0. Now we do need to talk about this special case right here. Notice how you have two coordinates that have a 1 for the y value. If the number appears more than once on the graph, you still only write it once over here. So you're only going to write -5, 0, 1, and 4. You're not going to write 1 twice. And then whether it's a function or not, if we don't have any, it's kind of easier to see in my opinion when you've got coordinates, like you don't have any two coordinates that are stacked on top of each other. So if you draw a vertical line anywhere in this graph, you're only going to hit like one coordinate at a time. So that would be a yes. This one is a function. Okay, I'm going to grab my food out of the microwave and give you guys a second to look at the domain. Take your best educated guess for what you think that domain is, and I'll be right back for what the domain should be. So remember that the domain is your x values. So if we're looking from left to right on the graph, we notice this is the left side of the graph. That is the right side of the graph. Those arrows tell us that it is going forever in both directions, to the left and to the right. So what do we use when it is going forever and ever and ever and ever and ever in a particular direction? What is the symbol that we use for that? The only issue is that ClassKick won't let us type it in there. Exactly. So technically we want the infinity symbol. ClassKick won't do that for us. So we're just going to use an I. Yes, sir. And remember, since it's going to the left forever and ever and ever and ever, it's going to be a negative infinity. Remember, we're just going to use I's for infinity since we can't. Actually, I just learned a way to put infinity into ClassKick, but I just learned it yesterday, so we're obviously not doing it today. And it's going forever and ever and ever in the positive direction as well, so we need a positive infinity or just an I. And you never put the square brackets around infinity because it's really more of a concept than it is an actual value. So we're just going to put the soft parenthesis on either side. Any questions about where I got that, gentlemen? We got all gentlemen here, I believe. Yep. The range is a little bit tricky for this one. So remember that your range is simply your y values. And because this is a flat horizontal line, it actually only has one y value. This graph goes through the 3, and that's the only y value that it goes through. So this time the range is just going to be 3. Now, because it's only the number 3, it's not, between 3 and something else. We are not going to use interval notation. So even though this is a continuous graph, that would help if I would spell that right. So it is continuous. And even though we typically use interval notation when we're dealing with a continuous graph, in this case, the range is literally just one number So when it's only one number, not an interval, we're still going to use those little curly Q braces. So since you're only listing the one number, you're going to put the braces on either side of it. And then, is this a function? If I draw a vertical line through it, it only hits it in one spot, so it passes the vertical line test. So that would be a yes. I'm going to slurp a bite of my lunch for a second. Anybody got questions about number 4? All right, cool. Let's go over to page 2. And sorry, y'all, now I'm going to start talking mouthful, but we can deal. All right, so y'all take just a second. Take a look at number 5. Get an idea in your head of what you think the domain and range might be. I'm going to tell you, though, in just a second. All right, so this applies to basically any single time you have a straight line that is graphed, and it is graphed at an angle. Okay, so for example, I'm going to start with this side of the graph right here. So that arrow tells me, because it's on a diagonal, technically it's moving to the left forever and ever and ever, right? But it's also moving up at the same time. That's what a diagonal does. It's moving to the left and it's going up at exactly the same time. So that arrow tells us that the domain, because we know the domain are x values, or whether or not we're going, how we're moving from left to right, right? So our domain is a negative infinity because that arrow on the diagonal tells you that it is moving to the left forever and ever and ever, right? So part of our domain is going to be negative infinity. But I want to go ahead and talk about the range at the same time. Because this same arrow, since it's diagonal, it's moving to the left forever and ever and ever, but it's also moving up at the same time because it's diagonal. So that part of the range, that high point, is going to be a positive infinity, right? It's moving to the left, which applies to the domain. So that's going to be a negative infinity. It's also moving up at the same time. So we know that our range is going to involve a positive infinity. Now let's look at the arrow in that direction. So it's moving, again, it's on the diagonal. So it's gradually moving to the right, but it's also moving down at the same time. So what do we use when it's moving to the right forever and ever and ever? That would be a positive infinity. So I'm going to finish out that domain, and we know we put parentheses around infinity. We don't ever do the hard bracket. And then because the range, this arrow tells us it's going down forever and ever and ever and ever. So that is going to be a negative infinity. So we should have a negative infinity and a positive infinity for the range as well. Basically, anytime you have a line graphed and it's on the diagonal, your domain and your range are going to be negative infinity and positive infinity. Because since it's on a slant, it's moving like up and down at the same time it's moving left to right. We know that this is going to be continuous because I can certainly draw that line without picking up my pencil. And if I were to draw a vertical line straight through it, it would only hit it in one place. So this would be a function. Okay, so moving on to number 6. Pretty much everybody got this right on the quiz. It was the reasoning that people were messing up on. Okay, so this is not a function. Okay, so the answer is no. But some people had the wrong reason why. A lot of people said, and this is the wrong answer, okay? A lot of people said it had to do with the fact that we had two of the same number for the y. That's not why it's not a function. It's not a function because of these two guys right here. That negative 1.5 with the 5.5 and the negative 1.5 with the 2.5. If we were going to graph those two coordinates, they would both be over, negative 1.5. They would both be over to the left 1.5, but one would be up here, at like 5.5. And then the other one would be way down here, at like negative 2.5. So because they have the same x value, but they have two different y values, okay, so same x with different y's, that's going to make them have two coordinates that when you graph them, they're like stacked on top of each other. Ugh, that was a really ugly line. But they're going to be stacked on top of each other, which means that they would fail the vertical line test. So when you're looking at a set of ordered pairs, that is what you need to look for. If you have, all your x's are different, then you're not going to have two coordinates that are, stacked on top of each other like that. But if you have two y's that are the same, two x values that are the same, but they have different y values to go with them, if you were to graph them, they would have two coordinates that are, stacked on top of each other, and we know that that would be not a function because that vertical line would hit them both. So the last part's our function notation. We are just doing substitution for the first two. So remember what that means is we're just going to take the function, okay? So I'm going to rewrite it down here. So I've got a little bit more room. So we're going to take the function, and it's telling us to take out the x and replace it with a negative 3. Okay, now this side right here, we don't really do anything with that side. Remember we talked about, my biggest bone to pick is I feel like the way that whoever decided to invent function notation, it's a little confusing about the way it's set up because it looks like you've got an equation with x's on both sides. All this side is doing is it's just telling you the name of the function, and you don't do anything else with it. Okay, so focus off the left-hand side. Now we're just going to look at the right-hand side, and we are going to take that x, we're going to pull it out of there, and we're going to replace it with a negative 3. So then you just do some simple evaluating. So 2 times negative 3 is negative 6. And then negative 6 plus 4 will give you negative 2. So the hardest part to just keep in mind is that this is basically just here for decoration. We're not doing anything else with that. It's just there to give you the name of the function. So questions about number 7 before we go on to number 8? All right, number 8 is the same idea. I'm going to take the original function. I'm going to write it down here, so 2x plus 4. However, now I'm going to replace the x, not with just a number, but I'm going to actually replace it with that entire expression of x minus 3. So remember, this guy, he's kind of done. We're not doing anything with him. We're just focusing over here on the right. So I'm going to replace that x with an x minus 3 because that's what it told me to do. plus 4. Now I need to do distributive property, so that'll be 2x minus 6. And finally, I've got like terms to combine. I'm going to combine that negative 6 and the 4. So my final simplified version is 2x minus 2. Questions about number 8 before we finish it out? TikTok. Okay, I'm going to assume we're good. All right, number 9. We're not really doing substitution with number 9. Okay, so take a look at what's happening here. I'll zoom in actually. All right, so we've got a 5 just sitting there next to the function. So what does it mean when you've just got a number sitting next to something? Remember, that means multiply, okay? So notice here, they didn't replace the x with a different number. So that means you're still going to just use the same function that you have in the original problem. So the function we had in the original problem is, of course, the 2x plus 4. So I'm going to rewrite 2x plus 4. So it's just the function I was given in the original problem. Because notice it doesn't tell us to replace the x with anything else anymore. It still says f of x. The only thing we need to do is take that and multiply it by 5. And again, the reason I knew I needed to do that is because the 5 is just sitting there next to the function, which implies multiplication. So we're just going to do good old-fashioned distributive property. So that'll give us 10x plus 20. You're just taking the 2x and the 4 and multiplying them by 5. That is all you're doing. No like terms to combine, nothing like that. So that's what I'm going to type in my answer box, is 10x plus 20. The part on number 9 that's confusing? Okay, so here, let me kind of, I know there's like a lot happening up there, so let me write it down here. And I'm going to put the problem, because I know there's like a lot happening in that problem. All right, so in the original problem, it told us that f of x is equal to 2x plus 4, right? In the other problems, it actually like gave us something different to put in for x. So, you know, for example, one of the problems was, you know, f of negative 3. They actually took that x out of there. Sorry, my thing's lagging for a second, guys. Every time I go to erase something, it takes a minute. There we go. So like in the other problems, they took the x out and they replaced it with a number, and that's what they wanted you to do. But notice in number 9, they didn't replace the x with a number, which means you need to just use it exactly the way it's written. So you're still just going to use 2x plus 4, just because that was the way it was written in the original problem, okay? But the fact that it's got brackets next to it and that 5 is just sitting next to it, that means you need to take the original problem and you need to multiply it by 5. So you're not substituting anything in there because they didn't give you a number to substitute. They just put a 5 next to it, which means they just want you to take it and multiply everything by 5. So that'll be 10x plus 20, just using plain old distributive property. The reason we had to use those brackets around it is because you already had parentheses inside of there. So we had to do it with the brackets instead. So you're just taking the original problem and you're multiplying it by 5.